right, welcome back. We're going to go over AWS Linear Learner. But before we start, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. So, AWS Linear Learner, simplicity and advanced machine learning. At its heart, machine learning begins with a simple question. Can we draw a line through data points to predict future outcomes? This concept, linear regression, forms the foundation of countless machine learning applications, from predicting housing prices to estimating sales revenues. Yet, what happens when you take this elementary concept and infuse it with the computational power and optimization sophistication of AWS? SageMaker's linear learner algorithm transforms the humble linear learner model into a versatile, high-performance machine learning solution that extends far beyond simple line fitting. While maintaining the interpretability that makes linear learner models valuable to business stakeholders, Linear Learner incorporates advanced optimization techniques that enable it to tackle complex real-world problems with surprising effectiveness. Okay. So, the evolution. So, how does this work? Traditional linear regression involves finding the best line through scatter-plotted data points. Linear Learner preserves this conceptual simplicity while dramatically expanding its capabilities. The algorithm can handle not just regression problems, predicting continuous numerical values, but also classification tasks, including both binary and multiple class scenarios. The versatility stems from Linear Learner's use of linear threshold functions for classification problems. Instead of simply fitting a line, the algorithm learns decision boundaries that optimally separate different classes in the feature space. This approach enables surprising applications. Linear Learner can successfully classify handwritten digits using raw pixel data, demonstrating that linear approaches can solve problems traditionally associated with more complex algorithms. The key insight is understanding when linear problems and models are appropriate. Not every data set is linearly separable. Some patterns require curves rather than a straight line. However, when linear relationships exist or can be engineered through feature transformation, Linear Learner often provides the optimal balance of performance, interpretability, and computational efficiency. So let's go under the hood a little bit. So how does this work? All right. So what distinguishes Linear Learner from basic linear regression implementations is its sophisticated optimization framework. The algorithm employs multiple advanced techniques that operate transparently to users while delivering superior performance. First, you have SGD, that's stochastic gradient descent. This serves as the primary optimization engine, but Linear Learner doesn't stop there, right? The algorithm also supports Adagrad and ADAM optimizers, ADAM. These automatically select the best approach for your specific dataset characteristics. This multi-optimizer strategy enables and ensures optimal convergence regardless of data properties. Then you have parallel model training. This represents another key innovation. So Linear Learner simultaneously trains multiple models with different hyperparameter combinations, then automatically selects the best performing variant. This approach eliminates much of the manual hyperparameter tuning typically required for machine learning projects. Then you have regularization. Through L1 and L2 penalties, prevents overfitting by constraining model complexity. This is what regularization is. Then Linear Learner applies these techniques automatically. So it balances the model's accuracy against generalization capability, but it doesn't require deep regularization expertise from users. So data prep, all right? Linear Learner's performance depends heavily on proper data preparation, but the algorithm provides significant assistance in this critical phase. The service accepts two primary input formats, each optimized for different scenarios. Record IO, protobuf format with float 32 data. This delivers optimal performance for production workloads. This AWS optimized format minimizes data transfer overhead and maximizes training throughput, particularly important for large data sets or resource-constrained environments. Then you have CSV format, comma-separated values. This provides maximum compatibility and ease of use for development and experimentation. When using CSV, Linear Learner expects the first column to contain label data with all remaining columns representing features. This straightforward structure makes data preparation accessible to teams without extensive machine learning engineering experience. The algorithm supports both file mode and pipe mode for data access. File mode downloads the complete data set to training instances before processing begins, suitable for smaller data sets and algorithms requiring random data access. Pipe mode streams data directly from S3 as needed, dramatically reducing startup time and storage requirements for large data set. Then you have data normalization. So this is crucial for linear learners' effectiveness. The algorithm can perform automatic normalization, but understanding when and how to apply it ensures optimal results. Features with vastly different scales can dominate the training or the learning process. And this makes normalization essential for balanced model performance. Then you have data shuffling. So this is another critical requirement. Linear learner benefits significantly from randomized input order, which eliminates biases that might exist from data collection patterns. The algorithm can handle shuffling automatically, but ensuring proper randomization improves training stability and final model quality. So let's get a little hands-on and see what we can do. Let's see, go over here. Why am I not able to spell? Is it not here? Um, oh, is it only going to go to documentation? Oh no. Entities, data sources. Um, this should be under SageMaker, but huh. All right, let's see SageMaker AI. Let's go to training. Let's see. Okay, let's try this. All right. So we'll do it. It's in SageMaker AI. All right. So this interface will help you with the pathway. All right. So we're going to create a training job to initiate the workflow. The console presents the various algorithm options, and you'll choose whether you're going to do a built-in, and then you can do a lot within this. All right. So let's just do test job. Right. Alphanumerics. You can use hyphens, no spaces. The role of it. Oh crap. All right. Let's dump that. Let's dump that. Okay. Okay, SageMaker built-in. All right, so which one do you want to do for this? SageMaker built-in, your own algorithm resource, your own algorithm container, or an algorithm subscription for the marketplace. That's going to cost them a lot of money. Algorithm container and ECR, you're going to want to get this set up. So we'll just start with the built-in algorithm, excuse me. And then we'll choose this one. We'll see tabular, linear learner. All right. This selection will configure the underlying Docker containers and optimization framework. So this will eliminate the infrastructure concerns, right? So you see all this stuff is built out here. All right, the file, input file right here. All right, and then go down here. What's the instance type? Ooh, this is gonna take some big ones. All right, pause. So you have a lot of machine learning models. See that ML dot, and then the model type, and then the model size, right? Or the instance type, right? These are very large models, right? And then storage volumes per instance, let's say 4 instance count. No, let's just do 1. Keep alive period, let's say 5 minutes. Encryption key, this is optional, but you do want one when you're going into production. So you can either go for no or enter a KMS ARN, which we don't have a key for this, but I do have a key. So we'll just go no. That's for encryption, in transit or at rest. Okay. Maximum runtime, say 24 minutes. Let's go 25 minutes, right? Network isolation. So this is going to be important. All right. So let's see. Containers that run with the network isolation can't make any outbound network calls. This is required for machine learning. All right. Select the VPC, the default, secure subnets, subnet in an availability zone. Let's do 1A. And let's see if they'll do 2. Okay. Security groups to ensure your training jobs are able to go from resource to resource. Inter-container traffic encryption. That's always useful. Okay, and then hyperparameters. So, excuse me. All right, so let's go to what we've done so far. So you should have an S3 bucket to have the CSV file, which we talked about that. You're going to select the model, which we talked about. They'll go into that S3. The instance, we choose that for your training workload. I think we selected, what is it? ML4 large. So it'll have sufficient compute resources without excessive cost. It's still going to cost though. Larger data sets or time-sensitive training may benefit from a more powerful instance, like which will go down here. So ML4, the extra large, you can go to the 16 extra large, right? Or the 32 extra, these are big workhorse computers. Like think about your $200 laptop versus your $3,000 gaming computer, to give you a conceptual idea. All right, let me see. Where's the input? We just went over, there we go. Input mode. Okay, so you can do file, this will download locally, or pipe mode, right, which you talked about. And that's your input. And pipe mode is really good for your model streaming and reduces your training startup time and your local storage requirements. So we'll stick with file just because we're doing some, what do you call it? We're doing testing. We're just basically doing a prototype. All right. Hyperparameters. Let's go back down here. All right. So hyperparameters, this is the section that reveals linear learner sophistication and flexibility. So the parameters require careful consideration based on your specific type and performance. So let's see. I want to look for, okay, predictor type. All right. So this would be, you could do binary, multi-class, or regressor, right? So regressor is for continuous numerical predictions, binaries for two-class problems, multi-class is for multi-category scenarios. So this is a fundamental setting that determines the loss function and evaluation metrics, right? So we just do binary. I mean, we don't have any data that we're going to use, but just giving you an overview. Where is normalized? Okay, normalized data. All right, so normalized data. Set this to true, right? Unless you performed manual normalization. So this will ensure that feature scaling doesn't bias the learning process, particularly when you have features that span numerical or different numerical ranges. And then learning rate. Okay, so learning rate, if the default convergence seems suboptimal, lower values on, let's say, a 0 to 1 scale determines the training, right? So a lower value provides more stable training, but requires more iterations, while higher values like a 0.1 accelerates convergence, but risks overshooting optimal parameters. So you can set, let's see, you can set this based on your overfitting concerns. So start with a small value like 0.15, right? And then you can adjust based on your validation performance. Look, a higher value increases the regularization strength, but it may underfit your complex patterns. All right, and let's see. I am looking for mini. That's not mini batch size. Okay, so your mini batch size, this will balance your training speed and memory requirements. So larger batches, like 1,000, which is the default. So this will provide a more stable gradient, but require more memory. Well, smaller batch like 100 uses less memory, but may produce noisier training dynamics. All right. So we'll do 750. All right. And then your input data. Okay. So your channel name, train, input mode, pipe. We'll have it for file, content type. We can choose text, so CSV. This is if we had a text file and a CSV file, right? Compression type will save data, time, and cost, right? gzip basically zips up that. Record wrapper, we talked about that for processing. And the data source, S3, or we can do it from a file system. So we choose S3, fully replicated distribution. And then we set the S3 bucket. So you'd have to go up here to S3, select your bucket, copy and paste that location here. All right. Checkpoint. So for generating checkpoints, this is basically like saving your game, right? It'll be saved to another bucket. So you can save it in the bucket you have up here, right here, with a different path. Okay. And then you could have a local path if you want to have it in a localized place. And then you have your output for where you want it. So you can also do it to the same bucket with a different final destination. And an encryption key for output. You can always do that. I recommend that if you're doing production. And then you have your spot training. This is for lower costs. Basically, save your compute costs if you have fault toleration, meaning the instances won't be persistent or they're not guaranteed to be persistent. All right. And then you add your tags and you should be good to go. All right. So remember, SageMaker has appropriate S3 permissions through the IAM roles for both reading training data and writing the model outputs. So the role will require S3, like get object, put object, I think list buckets. But you basically need permissions for input buckets and then put object permissions for output locations, right? If you're working with sensitive data, consider enabling encryption for both data transit and storage. So that's why I mentioned the IAM, the KMS keys. That's important when you're doing production. And if you're working with sensitive data, consider enabling encryption for both data transit and storage. SageMaker supports KMS for model artifacts and training outputs. So it ensures data security for ML pipeline. And this is coming up because a lot of places are trying to use this. Banks, healthcare organizations, have to worry about transactions and everything. All right. So you can click the launch training job, which we're not going to do. And from here, because it's going to cost. All right. So from here, you can monitor your progress through CloudWatch and the SageMaker console, right? And the training duration varies on the data size set, the instance type, and the algorithm convergence, right? So it'll typically range from minutes for small data sets to hours for larger workloads. So it just depends on how much data you have in that S3 to go for. And the console will provide real-time updates on the training status, including like algorithm metrics, resource utilization. You can monitor these to identify potential issues like convergence problems, resource constraints, or anything else that might affect the training quality. And then upon completion, Linear Learner will save the model artifacts into the specified S3 output location that we pointed out. And these artifacts contain the trained model parameters and metadata necessary for inference deployment. And then, okay, so then at that point, you need to review your training metrics. You can assess your model performance, and then you can have standard evaluation metrics appropriate for your problem types, for any regression problems. And then they'll address the accuracy for any classification tasks. And then, let's see, where is it? I can never remember. Okay, so for finding the endpoint creation functionality, you're going to go under inference, and then you're going to go to models. All right, and then you can go to create model using your trained artifacts. Right. So this process will configure the inferences container and prepare the real-time predictions. And then you can create an endpoint configuration specifying the instance type and count for your inference infrastructure. But for initial testing, a single instance. Where is compressed model? Yeah, that's what we talked about earlier. The IAM role. Where is it? Well, you use the right model artifacts, use a model package. So you'd use this. Well, since we didn't create it, right? But it would appear here, right? And then from here, you could add a container. Oh, that's the second one. Excuse me. Remove that container. All right. So from here, you could basically, the instance would be able to be here, but for production deployments, you could configure some auto scaling configurations to handle the traffic load. And you deploy it and test it with sample data to verify the model works. So you see create model down here, and it'll return your predictions in JSON format. All right. So, okay. So use this, and these instructions will help you, right? But we don't want to incur costs because we're just doing a basic walkthrough. All right. So strategic applications. All right. So linear learner's versatility enables deployment across business scenarios where interpretability and efficiency matter as much as prediction accuracy, right? So we were talking about this earlier, right? Financial services, you can use linear learner for credit scoring, for fraud detection. So the model can be crucial towards regulatory compliance and business understanding, right? The algorithm's ability to provide feature importance rankings can help you explain decisions to both internal stakeholders and external auditors. So when you start seeing the X group is denied Y for, Z, that's what you can use it for. E-commerce, right? So e-commerce platforms can use Linear Learner for price predictions and customer segmentation. So fast inference and transparent decision logic support real-time personalization systems, right? So the algorithm's efficiency enables deployment in latency sensitive environments without sacrificing accuracy. Then you have manufacturing. Okay, so manufacturing would be able to use Linear Learner for quality control and predictive maintenance. So linear relationships often exist between sensor readings and equipment performance. So the algorithm's robustness to noisy data makes it suitable for industrial environments with imperfect sensor data. And marketing analytics, right? So teams can apply Linear Learner for conversion prediction and campaign optimization. So they can understand the feature contributions that help optimize marketing spend and how that works for their business. So the multi-class classification capabilities can support the complex customer journey and create models that work. All right. Okay. We talked a little bit about that algorithm. Okay, let's go to cost. So it's part of the SageMaker suite. Oh, they don't have it specifically here. All right. Well, all right, I'll give you the basics. All right. So training costs depend primarily on instance type and training duration. That's the basics you have to understand for AWS. A lot of on demand. Okay. So linear learners convergence typically results in shorter training times compared to more complex algorithms. So it reduces compute costs. Using spot instances, like we pointed out, for non-urgent training workloads can achieve an additional cost savings, usually 50 to 90%. Okay, so inference costs can scale with prediction volume and endpoint configuration. Linear learners' lightweight model can enable deployment on smaller instances and reduce hosting costs for applications with moderate traffic volumes. And multi-model endpoints can provide additional cost optimizations for scenarios involving multiple linear learner models. So consider batch transformation jobs for offline prediction scenarios rather than persistent endpoints. These jobs process large data sets efficiently without ongoing infrastructure costs. It's ideal for periodic reporting or batch scoring applications. All right, so how does this integrate with everything? All right. So linear learners' value multiplies through integration with the broader AWS machine learning ecosystem. So you can understand these integration points enable comprehensive machine learning solutions that extend beyond individual model deployment. You have S3, right? This enables seamless data pipeline construction and supports both batch and streaming data scenarios. Right? We talked about the file, we talked about pipes, all that stuff. So Linear Learner can consume data directly from S3 while outputting results to data lakes for downstream analytics processing. You have AWS Lambda. So this can trigger linear learner training jobs when new data arrives, enabling automated model retraining pipelines that maintain prediction accuracy as business conditions evolve. Then you have CloudWatch, which can provide comprehensive monitoring and alerting for both training jobs and inference endpoints. So it enables operational excellence and proactive issue resolution. And then SageMaker Clarify, which has model explainability features that complement linear learners' inherent interpretability, providing detailed feature attribution analysis for complex decision scenarios. So linear learner is the evolution of classical machine learning techniques for cloud native environments. If you maintain the conceptual simplicity while incorporating the advanced optimization and scaling capabilities, this algorithm can enable organizations to deploy sophisticated machine learning solutions without requiring extensive algorithmic expertise. So it's a balance of performance, interpretability, and cost effectiveness. And it makes Linear Learner a good component of any AWS machine learning strategy. So that's what we've done for this time. Before we sign off, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. Thank you. Have a good day.